Hello everyone, welcome to this new tutorial. I'm Adrian Campos, and today we're going to create together a mini real-time notifications app using Zustand and Socket.io. Would you like to add real-time notifications to your web projects in a simple and efficient way? Then this video is for you. We'll learn how to combine the power of Zustand, a lightweight and fast state management library for React, with Socket.io, which allows us to handle real-time communications between the client and the server. Socket.io is a powerful JavaScript library that enables real-time, bidirectional, and event-driven communication between web clients and servers. Built on top of the WebSocket protocol, it provides additional capabilities like automatic reconnection, multiplexing, and fallback options for environments where WebSockets are not supported. Initially, we will set up a basic Node.js project to utilize Socket.io on the server side. This project will consist of a single file designed to run on the server and listen to our requests. The only dependencies we will use for our backend project is to install Express, which is a Node framework, Socket.io, and cores. First, we import the essential modules. Express is a web framework for Node.js. HTTP helps in creating an HTTP server. Socket.io is used for real-time communication between clients and servers, and Cores enables cross-origin resource sharing. Here, we initialize the Express application and create an HTTP server that uses this Express app. We then initialize Socket.io with the HTTP server. The CORS options are configured to accept all origins and to allow GET and POST methods, facilitating the interaction between the client and server across different domains. Course middleware is added to the Express app to handle course issues, and Express.json middleware is used to parse JSON formatted request bodies. We define a post route /send where the server accepts JSON payloads containing a message and title. It then emits a push notification event to all connected Socket.io clients with this data. The server responds with a 200 HTTP status code and a confirmation message. This section sets up event listeners for new client connections and disconnections on the Socket.io server. It logs a message whenever a client connects or disconnects. Finally, we start the server on port 3000 and log a message to the console to indicate that the server is running. Our server is now actively listening for requests on port 3000 through the socket. To verify the connection, we can use Postman to send data to the specified path as mentioned earlier. We send a JSON with the message and title property that we defined in our service with Node and Express. Now, we're diving into Zustand, a state management solution that's gaining popularity among React developers for its simplicity and ease of use. Zustand is a small, fast, and scalable, bare-bones state management solution using simplified Flux principles. Unlike traditional Redux, Zustand doesn't mandate the use of reducers or middleware, making it much simpler to set up and use. The main difference between Zustand and Redux lies in their architectural approaches and complexity. Currently, we have already created a project from scratch with React, but we added CSS styles for the components and styling of the application. They are already previously created. The primary objective of this simple application is to demonstrate how to receive push notifications. For this, we have used React Router, CSS, Zustand, Socket.io on the client side, along with some additional components. Now we will install the main dependencies for our project. These include Zustand for state management, React Router for navigation, and Socket.io for client-side functionality. In this segment, we'll explore how to use Zustand to manage global state in a React application effortlessly. One of the key advantages of Zustand is that it simplifies state management without the need for providers or complex configurations, making it incredibly developer-friendly. First, we import the create function from the Zustand library. This function is used to initialize the store. We define a TypeScript type message that describes the structure of each message, consisting of a title and a message. Next, we define another type store, which outlines the structure of our store. It includes an array of message objects and a function setMessage to add a new message to the store. Now we create our store using the create function. This function takes a setup function where we define our initial state and the methods to update it. The message state starts as an empty array. The setMessage function allows adding a new message to the array. It uses the set function provided by Zustand to update the state. The set function is called with a callback that takes the current state and returns a new state, here appending the new message to the existing array. Now we will build our app component, which is where we will use the store we previously created. Step 1. Import necessary modules and components. We begin by importing necessary modules like React, useEffect, and useState from React library, outlet from React router DOM for nested routing, and navbar, a custom component. We also import I/O from Socket I/O client for handling real-time WebSocket connections and our Zustand store use message store. Step 2. Establish socket.io connection. We create a socket connection to the server located at localhost 3000. This socket will listen to events from our backend. Step 3. Integrate Zustand store. We utilize two selectors from our Zustand store. setMessage to update the state with new messages and notifications to fetch the array of message objects. Step 4. Set up effect for socket.io. Within a useEffect hook, we listen for push notification events from our server. When a new notification is received, we call setMessage to update our global state with the new message. We also ensure to clean up the event listener when the component unmounts, preventing memory leaks and unnecessary updates. Step 5. Render components. In the render section, we calculate notifications count by getting the length of the notifications array. This count is then passed to the navbar component to display. The outlet component is used to render the matching child route components. Now, we will use the store on the messages page to display notifications. Step 1. Import dependencies. First, we import React and our custom notification component, which is used to display individual notifications. We also import useMessageStore from our Zustand store, which allows us to access the state containing the notifications. Step 2. Access state with Zustand. Within the component, we use the useMessageStore hook to retrieve the message state from our store. This state holds an array of notification objects, each with a title and message. Step 3. Conditional rendering. In the return statement, we handle the rendering of notifications. The element serves as the container for our notifications page. No notifications case. We first check if there are no notifications available. If true, we display a paragraph with the text, "No notifications." Display notifications. If there are notifications, we iterate over the notifications array with the .map function. For each notification, we render a notification component, passing the title and message as props. We use the index of the notification in the array as the key prop, which helps React identify which items have changed, are added, or are removed. Finally, we can send notifications from Postman, emulating messages sent from another client. As we can see, this is done in real time. Thank you for watching today's tutorial on integrating Zustand and Socket.io with React to manage global state and handle real-time notifications. I hope this session has illuminated the power and simplicity of Zustand for state management in your React applications, especially when dealing with live data. If you found this video helpful, please give it a thumbs up and subscribe to the channel for more tutorials like this.